Okay. In the previous class, we were studying the unsymmetrical bending for unsymmetrical bending for the symmetrical sections, right? If I summarize what we have learned, for example, let's suppose there was an I section in that case because it is a symmetrical section, and what we would do, we will let's suppose if we were provided with some kind of load, and we have to if we have to calculate the stress that suppose this point A, then in that particular case, uh, our counter and in the
शुरू में सर आपकी आवाज सही नहीं आ रही सर।
second case,
बहुत ज्यादा
will transform this. Yes, just give me a moment. Is it clear now? Anyone?
Yes, sir.
So the idea was that in the case of symmetrical section, we would transform the movement onto the two principal axes, and then after transforming, we can apply this equation, and using this particular we are able to calculate the stresses at any point, for example, B, C, or whatever is the point in this cross section. But you have to remember that there were certain rules regarding the direction of movements. There were certain sign convention, and there was some convention distances onto the neutral axis, which were y and z. Therefore, for example, if not moving in the or in the positive direction, then we were supposed to take these distances as negative. Similarly, we also learned how to calculate the inclination of neutral axis. There was one formula that was tan theta is equal to Iz over Iy into tan alpha. In that formula, we that this alpha is the angle of this movement axis, and mentioned that cell is clockwise, then we were supposed it was in the counterclockwise direction, we would take this angle negative. This moment of inertia we can calculate using the sectional properties, and then we can calculate the inclination neutral axis. Now that was a brief summary of the unsymmetrical bending for the symmetrical section. Now from now on, we are going to start our next topic, which is unsymmetrical bending for asymmetrical section. Now, as we discussed in our first few lectures of unsymmetrical, let's suppose if this is
Excuse me, sir.
this kind, we have this kind of yes.
सर आपकी आवाज बहुत ज्यादा कट रही है सर, फिर इस तरह रिकॉर्डिंग में भी कटेगी। आप एक दो अपना इंटरनेट चेक कर लें।
Okay, let me. Is it any better now?
Yes, sir, quite better.
So if again there is some sort of distortion, just let me know. So coming on to this unsymmetrical section, for example, let's suppose we have this else angle section or the Z section. Now in this case, as we discussed in some of our initial lectures, that the centroidal axis or principal axis do not coincide. For example, if these two are the centroidal axis and we are provided with the load acting on the centroidal axis, and if we are supposed to calculate the bending stress at this particular point A, now in this case I cannot apply directly the flexural formula, because the reason is that the flexural formula is applicable when the moments are on the principal axis. So in the case of these unsymmetrical section, we know that our principal axis are somewhat inclined with respect to the original axis. Now let's suppose that the axis which I have shown with this red line is the principal axis, and this orientation of this axis is angle theta. Now in this case the whole idea is same. Again the same thing. First, if this is the load, then we have to transform this load onto the centroidal axis or on the axis which is perpendicular to the applied load. Then again I will shift it with respect into double arrow as per the sign convention which we discussed in the case of unsymmetrical section. Now the only difference is that in the case of symmetrical section we were supposed to transform these movement arrow onto the horizontal and vertical axis, because those were the principal axis, but in this case we will transform these movement on this inclined principal axis, so which I have shown with this green line. Now once you have transformed this movement onto this inclined principal axis, the next step again is the same, that let's suppose if I have to take the movement at this point A, I will take the distance to point A with respect to my principal axis, because it is obviously the perpendicular distance. For example, this is my equation, that sigma is equal to my over I. Now in the case of symmetrical section, let's say if we have a rectangular section, our distance y was from this principal axis to the point, if this is point A, then it was a straight distance or perpendicular distance from this horizontal axis to point A, this one. Now, in this case, when we have unsymmetrical section, obviously this is my principal axis. Now, in this particular case, my perpendicular distance, for example, if this is point A, then I have to take this perpendicular distance from my principal axis to point A. And similarly, if I have to take y distance, I will again consider the same thing, that or the distance. For example, in the case of rectangular section, if these are my two axes, y and z, then y distance is the perpendicular distance from this horizontal axis to the point under consideration, and similarly the x distance or z distance is from this y axis to the point under consideration. Now in this case, if this is z axis and this is y axis, then my y distance will be from this particular axis to the axis of or line of action of this point A. So this is how we take the distances that we have to substitute into this equation. Now you know how to get the movement. Same way you have to transform it onto two axes. The distances I have just discussed it briefly, that how you can take the distances and the moment of inertia, it remains the same. And another thing is that how to figure out that what are our principal axes or what is the orientation of principal axis. Now to figure out the orientation of principal axis, the idea is same, which we have learned. There is whole theory, transformation of moment of inertia. Now in this concept, just like we did for the case of transformation of stresses as strains. What we were doing that we knew what are the stresses on a particular axis, and then we would apply certain equations. For example, for sigma x, there was sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 sine 2 theta and so on. So we would apply this equation and we can calculate the stress at any inclined axis. So same is the concept with this transformation of moment of inertia. Now in this case, if you know the stress at if you know the moment of inertia at any particular point, you can use these kind of equations for the calculation of moment of inertia at any inclined axis. And in the same way, there is one equation for principal axis, that which are the axes on which this moment of inertia or second moment of inertia is maximum or minimum. Now, those are called as the principal axis of moment of inertia, just like we had the principal axis of normal stresses or normal strains. So this is how you calculate. But this derivation or this analysis is not part of our course. So I have just given you brief idea that what is the theory. The theory is same. You have to use the similar kind of equation that you derive for stresses and strain. But for this course, we are going to use directly the section table. Now for each kind of section, for example, if we have this L section and its dimension are 15 inches and 20 inches. Now for this section, there are section tables. If you see your mechanics book by Hibbler, at the end of that book, you have certain section table. Now in these table, for every type of section, for example, angular section or I section, there are some parameter. For example, if this is the section which I need to solve, then in that table I will be provided with all the details related to this section. For example, it will say that Ix for this one is 100 and Iy is 20. Similarly, it will also mention that there is a third axis or an inclined axis, let's say if it is a z axis, on which the principal or on which the second moment of inertia is maximum or minimum, or this is our principal axis. And it will also mention in that particular table that what is the orientation of this principal axis and what is the moment of inertia of this principal axis. And using those section table, we can calculate these parameters for any type of section. So you will see how we are going to do it when we will be solving the numerical problem. Now, any question about this one? So if there are no questions, then we can move on. Now, before moving on to the example problem, I just want to explain a simple concept. For example, just like I told you before, that in the case of symmetrical section, we were taking, for example, if I have to apply this particular equation, then in the case of symmetrical section, this y distance is the distance from this horizontal axis to the point on which I have to calculate the stress. But in the case of unsymmetrical section, the idea gets different. For example, if I have a z section, then in that particular case, why it is from this horizontal axis, because this horizontal axis is the principal axis by default in the case of symmetrical section. Now in the case of z section, obviously my principal axes are somewhat inclined with respect to the horizontal one, and if I want to calculate the stress at this particular point A and I want to know the what is my y distance, then that y distance is the perpendicular distance from this axis to the point on which, or this particular distance will be my perpendicular distance or my y distance for this particular section. Now, let's suppose if I have to calculate, one way is that usually we are provided with the horizontal and vertical distances. For example, I will be provided with this length that is 10 and this length maybe 11 and this length as 10. Now one way is that first for example, if I have to calculate the stress at point A, then first I have to know what is y distance, and then I will transform this y distance on the inclined axis. Now this particular work gets complex, and we may need to look for some alternate method, or there are some alternative equation. They have developed one generalized equation for the calculation of this y distance. For example, they say that if you know this y distance, there is some equation which correlates this y distance with this inclined y b distance. So there will be some equation that yb is equal to y cos theta plus z sine theta, and using this equation you substitute the original horizontal and vertical distances for any point, and you can get the inclined distances. Now there is just a brief derivation on how to do it. Let's suppose we have this z section which I have shown in this figure. Now in this z section, this y dash and z dash are my original horizontal and vertical axis. Okay, and this y and z are my principal axis. Now let's suppose it has been asked that I need to calculate the stresses at this point B. Now obviously for movement, I have the moment, I will transform this moment onto my principal axis. For example, this is the moment that is acting on this section, and these moments have been transformed on the principal axis, and I will just substitute these values into my flexural formula. Now the problem is again that what will be my y distance and z distance. Now in this figure, this is point B, and this yb distance is shown over here. For example, this is the principal axis, and the distance from this particular point to this point will be yb distance, or in other words, this distance is the perpendicular distance from the principal axis to the point under consideration, right? And in the similar way, just like we were used to do in the case of rectangular section, this zp distance uh, is the distance from the original principal, or from the principal plane, or perpendicular distance from the principal plane to the point under consideration. Obviously I can show this zb distance over here as well. For example, this distance will be from this point to the point B, or line of action of point B. So this is my ZB distance. So it is the same distance which has been shown at the top. You can show it over here and you can show it over there. So I have to use in my flexure formula this moment mz, then this distance yb over iz. This is for the principal axis, right? Now I want to correlate this distance zb and yb, this is yb, with my original horizontal and vertical distances. For example, let's suppose if it was a symmetrical section, then my y distance would be from this central point to this point B, which is this particular distance, right? This will be my yb dash. And similarly, my z distance, or the distance in the z axis, will be from this central axis to this point B, and this is my ZB distance. Now the idea is that I want to correlate these two distances, YB dash, ZB dash, with these inclined distances. And the purpose is that once I correlate these one, I will have direct equation to get this inclined distances considering this horizontal and vertical distance. I don't have to transform it again and again. Now, can anyone tell me what will be this angle? Anyone?
दोबारा बता दीजिए सर क्या?
How much?
दोबारा पूछिए, आपने क्या पूछा?
What will be this angle which I have shown with the green pointer? This one. Khizar.
Yes, sir.
ये एंगल कितना होगा?
सर एक्चुअली मेरा इंटरनेट थोड़ा सा मसला हो रहा है, तो आई गेट डिस्टर्बेड बार बार, तो मुझे ये वीडियो दोबारा देखनी पड़ेगी.
151.
नो आइडिया.
552.
Sir, maybe tan theta is equals to yb dash over zb dash by 2. Maybe, sir.
मतलब इस फिगर में देख के आपको क्या लग रहा है ये एंगल कितना होना चाहिए?
मतलब मुझे
सर थीटा ही होगा सर, जब नीचे एंगल थीटा है तो ऊपर भी थीटा होगा.
So this angle is angle theta because अगर ये यहाँ से ये थीटा डिग्री रोटेट हुआ है तो ये एक्सिस भी तो थीटा डिग्री रोटेट होगा. ऐसे ही है.
yes, sir.
So this angle is theta, and if this particular angle is theta, तो ये angle, अब can I say that this length which I have shown over here, or which is my, I will just say is this one. Can I say that this length YB and this length is also YB, right?
Yes, sir.
Because
Yes,
both
sir.
of these
Yes,
lines
sir.
are parallel and equal in length, so I can say that this length is YB, and this horizontal length which I have shown with the green line over here, which is YB dash, or this particular length YB dash, I can also represent it over here, right? So this
Yes, sir.
horizontal
Yes, sir.
distance is my YB dash, or the original vertical length. And since the angle between YB dash and YB over here is theta, so I can also conclude that this particular angle is theta, because over here it is theta, which is the inclination of principal axis, and over here I can also say that this angle is theta, and over here this particular length is theta as well. Now, any confusion about this diagram?
सर
No,
नो सर.
sir.
एक्सक्यूज मी
So
सर.
if the, yes,
सर ये दिखाई हटा दे दोबारा, सर पता ही नहीं चलता आप कहाँ लिखाई कर रहे हैं, क्या कौन सा पॉइंट शो कर रहे हैं.
क्या चीज?
जो है सर इसको रिमूव कर दे सर, तो पता चल जाएगा कि आप किस पॉइंट.
Actually, I want to calculate the stress at point B. Okay, so this is my point B and I want to calculate the stress at this particular point. ठीक है, अब उसके लिए मैं क्या कर रहा हूँ, मुझे डिस्टेंसेस फ्लेक्चरल फार्मूला के लिए दे YB and ZB चाहिए, and I am trying to develop a correlation of these inclined distances in terms of this original straight and vertical distances. So there are certain angles which I have explained कि ये कैसे, how this angle is theta, how this particular angle is theta, how this distance is YB dash, and why I am taking this inclined distance as YB, because it is same as this one. So now we have the distances, and now we want to correlate our horizontal or vertical distances with each other. Now, can anyone tell me what will be this length from which I have shown between these green lines? What will be this length?
This will be sir YB sir, which is and
The inclined one.
Yes, sir.
No, YB is this total
Sir,
length.
sir, y dash cos theta. Y
So
b
can
dash
I
cos.
say, okay, this is making things confusing. This YB is the total length. You can see from here that this YB is the total length, and this, which I have shown with the green pointers over here, is, let's call this length as A. So A is equal to YB dash cos of theta, right?
Yes, sir. Yes, sir.
And what will be this length B?
Sir, z b dash sin theta.
So B is ZP dash sine of theta. Now I know that this total length is equal to YB, or I can say that YB is equal to A plus B, or YB is equal to YB dash cos of theta plus ZB dash sine of theta. Now this is one generalized formula फॉर द कैलकुलेशन ऑफ वाई बी. अगर आप मैन्युअली करते तो क्या करना पड़ता आपको, वाई बी डिस्टेंस को भी ट्रांसफॉर्म करना पड़ता, जेड को भी ट्रांसफॉर्म करना पड़ता, एंड देन यू वर सपोज टू कैलकुलेट or you will get yp. Now in this case you have generalized formula. For example, if I ask you to calculate the stress at point B, you will measure the straight distances which are this yb dash and where is the other one, this zb dash. And if you know the inclination or this angle theta or this particular angle theta, you will simply substitute that angle into this equation and you will directly get this yb distance. And now this yb distance you will substitute into your flexure formula for the calculation of stress. Now this is one distance. Obviously we have the other component as well, that is for in the z direction or zb direction, right? So in order to get that particular distance, again we will apply a small transformation. So over here, can anyone tell me what is this distance? Let's call this as c. ये कितना होगा?
Sir, y b dash
Y b
sin
dash
theta.
sin theta.
So I can say that c is yb dash of sine theta. What will be this total distance? Let's call this as d. तो ये total distance कितना होगा?
Z b dash cos theta. Z b
How
dash
much?
Z b dash cos theta.
If I look into this triangle, this particular triangle, now in this triangle, there is this distance inclined one. Now this distance is obviously zb dash cos of theta, and this horizontal distance which is shown over here is equal to this distance which is shown in this triangle, right? So I can say that this distance is zb dash cos of theta. Now can I say that zp, which is this particular length shown over here, is equal to d minus c. D is the total length and c is this component. So if I substitute these two conversion factors into this equation, I'm going to get zb equals to zb dash cos of theta minus yb dash sine of theta. Now this is my equation or correlation for the calculation of yb, the zb component or the inclined component. Okay, so you can use this. So this was the brief idea on how to calculate the distances. But again, you have to be very careful while substituting the signs of these distances. For example, you will be provided with the original horizontal and straight length. Now, we have fixed our sign convention that if positive z-axis is towards the left and positive y-axis is towards the top, then in this case, for example, if your point is somewhere over here, let's say this is point B and you want to calculate the stress at this point. Now in this case, your zb dash distance will toward the right side, let's say it is 10. Now in this case, you have to substitute minus 10 in this equation. And similarly for the angle theta, the angle from the original vertical axis and the inclined principal axis is in the counterclockwise direction. Now, for example, let's suppose if your principal axis comes out to be this one. Now, in this case, your angle between y dash and y is clockwise. If this is the case, then you have to substitute the negative sign with the angle as well into this equation. And if this case is same one, for example, if you have a counterclockwise orientation, then you can substitute the positive sign with the angle on. So the conclusion is that you have fixed your sign convention. अगर आपकी सारी चीजें इस फिगर के अकॉर्डिंगली आएंगी क्वेश्चन में, तब आप पॉजिटिव में सब्स्टिट्यूट करोगे। और अगर इससे कोई भी चीज डेविएट करती है, फॉर एग्जांपल y डिस्टेंस करता है या z डिस्टेंस करता है, then you have to substitute the negative sign with that particular parameter to get the correct answers for these inclined distances. So any question about this one?
सर ये 2B थोड़ा रिवाइज करेंगे, समराइज टाइप।
2b
जिससे 2B कहाँ से आए ग्राफ में से, इस डायग्राम में?
ये 2b नहीं है, this is zb.
ओके सर, आई गॉट इट। 2B
So this is a brief idea about how to transform the distances. Now let's start with one example problem, after which we will have a clear idea on how to tackle such questions. Let me share one question with you. Yes.
सर ये आई का क्या होगा? आई जो होगा सर वो इंक्लाइंड प्लेन की बजाय फिर स्ट्रेट वाले, मतलब जो परपेंडिकुलर पहले ओरिजिनल एक्सिस थे उसका आई यूज होगा। मोमेंट ऑफ इनर्शिया की बात।
आई किसका यूज होना चाहिए, आपको क्या लगता है?
यूज तो सर इंक्लाइंड प्लेन का होना चाहिए सर।
इंक्लाइंड प्लेन क्या चीज है? देखो ये टर्म नहीं यूज करनी है आपने के
प्रिंसिपल एक्सिस की सर।
हाँ, प्रिंसिपल का, क्योंकि इंक्लाइन पे भी इनफिनिट नंबर ऑफ प्लेन्स हैं, हमें आई चाहिए प्रिंसिपल प्लेन्स का। तो इस केस में ऑब्वियसली प्रिंसिपल प्लेन्स इंक्लाइंड है और उनका एक आई फैक्टर होगा।
सर मतलब जेड भी और वाई भी फाइंड करें तो उससे आई मोमेंट ऑफ इनर्शिया ही निकाल देंगे फिर
हैं?
जब सर डिस्टेंस फाइंड हो जाए सर, फिर हमने इससे वो फाइंड करनी है मोमेंट ऑफ इनर्शिया।
नहीं, मोमेंट ऑफ इनर्शिया के लिए ना असल में ट्रांसफॉर्मेशन इक्वेशंस हैं, जिस तरह स्ट्रेसेस के लिए नहीं आपने पढ़ी थी कि अगर आपके पास स्ट्रेट एक्सिस पे दी होती थी स्ट्रेस, फिर आपने इक्वेशन बनाई हुई थी एक सिग्मा थीटा की, और आप उसमें सब्स्टिट्यूट करते थे सिग्मा एक्स और सिग्मा वाई। इसी तरह आई एक्स और आई वाई गिवन होता है एंड देन यू हैव इक्वेशन, बट दैट इज नॉट पार्ट ऑफ आवर स्कोप। तो हम ज़्यादातर जो यूज कर रहे होंगे वो सेक्शन टेबल यूज कर रहे होंगे। उन टेबल्स में आपको प्रिंसिपल एक्सिस का मोमेंट ऑफ इनर्शिया गिवन होता है। सो लेट्स सपोज इन क्वेश्चन में आपको आई जेड एंड आई वाई विल बी provided, or you have to use the section table to get the IZ and IY, right? I will share with the derivation. If you are interested, then you can also have a self-reading and we can discuss it.
Okay, fine.
So this is one question, and in this question we are provided with this angle section L6 4 multiplied by half. So this particular statement or this notation is the you can say designation of this angle section. So every angle section, we have standard section that we use in practice, and each section has some sort of designation. And the purpose of designation is that these properties of this section are summarized in the section tables which are available. So if you see Hibbeler book, you will find out that there are section table provided at the end of the chapter or at the end of the book. Okay, so on in the question it says that we have this angle section which is used as a simply supported beam. Now by that it means obviously that the longitudinal length is 48 inches and there is a load of 1 kip that is acting on this beam in the midspan. And what we have to do is we have to calculate the angle between the neutral axis and the horizontal, or I can say that we have to figure out the inclination of neutral axis. We have to mention or we have to calculate that where is our neutral axis. Okay, and in the second step we have to figure out the maximum bending stress. So that means we have to it is up to us or we have to figure out that where is the point on which the bending moment or maximum bending stress is occurring on this angle section. So first step obviously is that we have to write down the dimensions of this section. Now let me share the section table with you. Now if you see in the book, there are these sort of tables which are provided at the end. So you have to look for your section which has been given in the question. Now in this section, if you see, let me just zoom it. Now in this section or in this table, if you see that this section which I have shown in this red box, this is our section which is given in the question, that is L6 by 4 multiplied by half. So this is our section and there are certain properties which are mentioned. For example, it has given us the area of this section, the moment of inertia with respect to this x-axis. Now there is also a designation of this. Now you have to be very careful uh, while selecting the values from the section table. For example, in every table, it will provide you with the standard values. For example, it says that this is my x-axis and this is my y-axis. Now, in some cases, you might also see that it will say that this is z-axis and this is y-axis. Now, you don't have to be, should not, you should be very careful while noting the dimension. And for example, in this case, it has mentioned that the horizontal one is the x-axis, but if you remember, we are using the term z-axis for our horizontal axis, so don't confuse both these terms. And similarly, over here, it has mentioned that there is a y axis, which is this vertical axis, and for this y axis, it has also provided us with this moment of inertia. And the next thing is there is an inclined axis, which is this z axis. Now this inclined axis, in every section table you will find this particular inclined axis. Now this inclined axis is your principal axis. Okay, so this is my principal axis, and in this table, if you see, it has provided me with this angle alpha or the inclination of this inclined principal axis So I know that from the section table, I can figure out that what is my inclination of principal axis, and it has provided with me with another term, that is this radius of gyration. Okay, now using this radius of gyration, I can calculate the moment of inertia of this particular section or of this inclined principal axis. So because I know the area is 4.75, the radius it has provided me as 0.864, and I will simply substitute it back into my equation of R, and I can calculate that what is my I for the principal axis. Now, any question about this one?
No, sir. No, sir.
Just give me a moment. Okay, I am giving you this table. Take 2 minutes and write down the dimension of the angle section which is being provided in the question, and I'll get back to you. Okay, now let's just finalize the dimension of our section. For example, in our question, okay, one thing I missed, that in this not in this designation of this particular section, this first term over here represents your you can say the total height of this section. For example, if it says that this is L6, that means the total height of the section is 6 uh, the units are
Inches.
inches over
Yes.
here, so I can say that the total height is 6 inches. And the third term over here represents your, you can say, thickness of this particular section. For example, that is half inch thick. Okay, now if let's suppose these are my centroidal axis, which I will name as, this is my z dash axis. And why I'm naming it as z dash, because I have done the previous derivation with respect to z dash axis and y dash axis, so I will use the same terms. So can anyone tell me what will be this distance? What will be this top height or this vertical distance, looking into this
So
section
3
table?
inches. 3.
How come? Anyone else?
सर फाइंड करना पड़ेगा न्यूटन लेग्स, तो जरूरी नहीं है कि सेंटर को।
किससे फाइंड करना पड़ेगा?
सर सेंट्रॉइड जब फाइंड कर रहे हैं तो एक्स वाई की पता चल जाए सर इस तरह से।
ऑब्वियसली दैट इज द मेथड। एक्चुअली में होता वही है कि जी आप सेंट्रोइड फाइंड करो और देन यू फाइंड these distances. But again, the point is why we are using these tables. In these table, everything will be provided to you. Because वो चीज़ें अब हमारा पार्ट नहीं है स्कोप का कि हम दोबारा से सेंट्रॉइड फाइंड करें और ये डिस्टेंसेस फाइंड करें. So we are going to use this section table. Now in this figure, if you look into this,
1.95 क्यों है ना सर?
there is a y
2.06
distance.
होगा।
There is a y distance which is mentioned in this figure. Okay, this is the y distance, and in this section table, if you see that this is the column of y, and if I look into this one, it has mentioned that this y distance is 1.98 inches, right? Is this clear?
Yes sir, yes sir, yes sir, yes sir.
So what will be this distance?
6 minus 1.
सर लेकिन आपको वाई वाई कंडीशन वाई वाई पे करना चाहिए था ना।
देखो वही मैं आपको कह रहा था कि y पे क्या करना चाहिए था.
सर क्योंकि जो हमने हॉरिजॉन्टल वर्टिकल डिस्टेंस फाइंड करना था ना, तो हम एरिया वाई एक्सेस वाई वाई का नहीं लेंगे, लेकिन वो एक्स क्यों दे रहा है सर, मुझे इस चीज की समझ नहीं आ रही।
नहीं, आपने इस चीज से कंफ्यूज नहीं होना कि वो x ले रहा है या y ले रहा है. आपने इस डायग्राम को सिमिलैरिटीज फाइंड कर लेनी है. ठीक है, अब आप ये देखो, ये भूल जाओ कि ये y क्या है या फलाना किस एक्सिस पे है. आप मुझे ये बताओगे इस फिगर में y है क्या चीज. इट इज द डिस्टेंस फ्रॉम द सेंट्रोइडल एक्सिस टू दिस हॉरिजॉन्टल लेग. ऐसे ही है, इस हॉरिजॉन्टल सेंट्रोइडल
यस
एक्सिस से लेके हॉरिजॉन्टल लेग तक का डिस्टेंस है y. अब इधर मैंने क्या किया है, सेंट्रोइडल एक्सिस ये है मेरा z डैश, इधर से लेके हॉरिजॉन्टल लेग के टॉप तक का डिस्टेंस मैंने मेंशन कर दिया कि दैट इज सिमिलर टू दिस y डिस्टेंस. ऐसे ही है.
यस सर, यस सर।
So what will be this remaining distance?
4.02.
4.02. Okay. Actually, this z-axis is. Let me just plot this again. Let's suppose that this is my other axis. Now, what is this total distance for this in this horizontal direction? Again, this distance you will get to know from this designation. The second number in your designation is the horizontal distance, that is 4 inches for this angle section, right? So this is your horizontal distance. Now tell me what will be this distance.
0.981.
981
So again, if I look
0.981.
into this figure over here, I can see that x distance which is shown over here is 0.981, and if I compare my figure, I can get idea that this is 0.981, and what will be the remaining distance?
3.11.
3.019 or 3 point. So now I have completed my diagram. Okay, there is one thing that is still remaining. What will be I y dash? You can also get these from the section table. What will be I y dash?
So 6.22.
So I know that my vertical axis is y over here in the section table and my axis is y dash. So for this y axis, if I look into this figure, I've been provided with IY, which is 6.22. So I can say that IY dash is 6.22 inch 4. And what about IZ dash?
So आपको कैलकुलेट करना पड़ेगा ना, r इज इक्वल्स टू,
IZ dash.
नहीं सर
It
वो
is
होगा
also given
सर
directly over here.
17.3,
So that
17.3
is 17.3 inch 4. Okay. So now let's suppose this blue axis are my principal axis. I will call this as Z and this vertical one as Y. What will be the inclination for this particular angle theta?
23.75 degree.
So again, as I told you previously that I will use this formula. Now in this one, if you see that I have been provided the counterclockwise angle as angle alpha, and the value of angle alpha is, or tan alpha is given to me as 0.440. So tan alpha is 0.440, and if I simplify this equation, I will get angle alpha as what will be the value? Someone told me
23.7.
23.75.
23.8. So
जी.
I can say that this angle is 23.8 degrees. Now I know the inclination of my principal axis with respect to the original horizontal and vertical axis. This angle will also be 23.8, and you can also calculate this interior angle. So this is the inclination.
Excuse me sir.
Yes.
सर इधर तो टेबल में बिल्कुल सारे जो वो थीटा दिया सर वो सारे एंटी क्लॉकवाइज है सर, क्लॉकवाइज हो तो उस पर
हाँ,
क्या करने का, तो क्लॉकवाइज
तो
दिया गया है।
क्लॉकवाइज होगा तो क्या करेंगे? आप कहोगे कि आपका प्रिंसिपल एक्सिस इज समवेयर लाइक दिस वन, मतलब विद रिस्पेक्ट टू वर्टिकल आप क्लॉकवाइज रोटेट करके उसको बना दो।
ठीक है सर, लेकिन इधर एंगल की बात करूँ, टेन थीटा क्या है, जो एंगल दिए गए हैं मतलब वैल्यूज सर ये सारे काउंटर क्लॉकवाइज के लिए दिए गए हैं, फिर यही पुट कर देंगे क्लॉकवाइज के लिए भी।
देखो अब इस टेबल में ना आपको हमेशा दिए ही काउंटर क्लॉकवाइज होगा, क्योंकि उसने किसी न किसी रिस्पेक्ट से देने हैं ना, वो क्लॉकवाइज बनाएगा ही नहीं, उसको क्या जरूरत है? अगर वो क्लॉकवाइज बनाता है तो उसका ये मतलब होता है कि वो ये वाला एंगल दे देता है आपको, क्योंकि प्रिंसिपल एक्सिस तो फिक्स हो गया ना, अब सब एंगल सेक्शंस के लिए यही होगा। वो
ठीक
आपको ये वाला एंगल दे देता, आप वो कैलकुलेट करके वो डाल देते, बात वहीं आ जाती कि अल्फा फिर उतना ही आना था।
यस सर।
ठीक है, तो यू हैव दिस एंगल एज 23.8, and what will be your IZ now? Or first let's calculate IY, because IY is directly given in this diagram. So what will be your IY? Now you have to be careful. IY is our this axis, which is shown with the blue line. This is my IY. So can anyone tell me what is IY?
यस सर, आई जेड डैश साइन थीटा प्लस आई वाई डैश कॉस थीटा।
ये कैसे आपने किया?
जी सर।
Yes, yes.
आपने सर क्या बोला?
मैं कह रहा हूँ आपने ये कैसे कहा है कि ये,
सर पिछले डेरिवेशन जो किया था सर।
वो तो डिस्टेंसेस की डेरिवेशन थी। दिस इज आई एम टॉकिंग अबाउट मोमेंट ऑफ इनर्शिया।
ओके।
सर रेडियस ऑफ
सर
जायरेशन का
ट्रांसफॉर्मेशन
फार्मूला यूज
इक्वेशन
करेंगे।
लगा
सो
देंगे।
आई हैव बीन गिवन, देखो ट्रांसफॉर्मेशन इक्वेशन मैंने आपको बताया है, लेकिन वी आर नॉट गोइंग टू यूज इट मच इन दीज इक्वेशन, बिकॉज हमने वी आर नॉट doing that derivation. So in these questions, you will be directly using uh, your section table, and one or two concepts you may use from that equation. Okay, so if you want,
Okay,
you
sir.
can try to get used to that one as well. So anyway, coming back onto this one, we have been provided with this radius of gyration, that is r is equal to I over a for my vertical axis. For example, for this z axis. Now in my case, I have taken this axis as Iy, so I can say that my Iy is equal to Iz with respect to the section table. Anyway, I will call this as Iy over here. Now I know that this R is given to me as 0.864, and the IY I need to calculate, and the area of this section is 4.75. So what will be my IY by solving this equation?
सर हमें कैसे पता चलेगा कि हमें आई वाई चाहिए या आई जेड चाहिए?
हमें तो दोनों चाहिए.
So 3.54.
सर अच्छा हाँ ठीक है.
3.546 inch 4. Now I have Iy with me. That is the moment of area or moment of inertia of this y-axis or this inclined vertical axis. Now I have this value and I need to figure out Iz. So can anyone tell me how I can get Iz? Because it is not given in the section table. In section table, you are provided with only one moment of inertia of principal axis, which was for this vertical axis or inclined vertical axis. Now, how can I get the moment of inertia of the z axis? You have to use one concept from transformation equation.
सर इनका सम सेम होगा ना ताकि
Just like
ट्रांसफॉर्मेटिव
in the
वाला?
case of stresses, if you remember
Would
that sigma x plus sigma y was equal to sigma x dash plus sigma y dash, right? So same concept applies
यस
over
सर.
here, that Iz plus Iy will be equal to Iz dash plus Iy dash. So you have to use this particular equation to get the Iz. So what will be Iz for my case?
nineteen
So
19.98 something
so if I
at 20.
substitute all these values, I will get Iz as 19.98 inches. Now, over here, I have summarized all the geometric properties of my section, which was given in the question, by using the section tables or by using a brief concept from the transformation equation. Now I'm going to stop over here and we will continue with the same example in the next class. Meanwhile, I expect you to review the lecture before coming into the next class so you can understand exactly what we are doing. So any question about this one?
सर हम लोग दो स्ट्रेसेस क्यों निकाल रहे हैं लाइक सिग्मा वाई और सिग्मा जेड अलग-अलग से? इसका बता दें.
सिग्मा y और सिग्मा z हमने अभी तो कुछ भी नहीं
यस
कैलकुलेट किया. हम तो एक ही करेंगे.
सर वो आपने कहा ना स्टार्टिंग में कि हम सिग्मा वाई भी करेंगे और सिग्मा जेड भी, तो उसकी रीज़न क्या है कि दो दो स्ट्रेसेस निकालने की क्या रीज़न है यहाँ पे?
नहीं, स्ट्रेस हम एक ही निकालते हैं. फॉर एग्जांपल लेट मी जस्ट एलैबोरेट. अब जब आपके पास ये इस तरह का सेक्शन होता था, ठीक है, और आपने इस पॉइंट पे स्ट्रेस निकालनी होती थी, मोमेंट आपका किधर होता था? इस एक्सिस पे, हॉरिजॉन्टल एक्सिस पे।
यस सर, यस सर।
ठीक है, मतलब एक एक्सिस, एक प्रिंसिपल एक्सिस पे मूवमेंट है, मूवमेंट ऑन वन प्रिंसिपल एक्सिस। अब इसकी वजह से ए पॉइंट पे अगर मैंने स्ट्रेस निकालनी है तो वो सिंपल हो जाएगी एम वाई ओवर आई, राइट। अब लेट्स
यस
सपोज
सर,
मैं
यस
आपको
सर।
कहता हूँ कि इंक्लाइन लोड लग रहा है। अब इंक्लाइन लोड की वजह से मूवमेंट इंक्लाइंड हो गया, ठीक है। अब जब मूवमेंट इंक्लाइन हो गया है, इसको मैंने करना है ट्रांसफॉर्म, इसको मैंने अपने प्रिंसिपल एक्सिस पे लाना है। तो एक मूवमेंट ये होगा, एक मूवमेंट ये होगा। अब इन दो मूवमेंट्स की वजह से ए पॉइंट पे स्ट्रेसेस लगेंगे, ठीक है। तो एक स्ट्रेस को
ठीक है
मैं
सर, हम
कहूंगा
रिजल्टेंट।
एम जेड वाई
ओके
ओवर आई,
सर,
और दूसरे को
रिजल्टेंट
मैं
है।
कहूंगा एम वाई जेड ओवर आई। और ये मेरे पास टोटल स्ट्रेस होगी ए पॉइंट पे।
ओके सर, समझ आ गया। थैंक यू सर, थैंक यू।
तो एनी अदर क्वेश्चन? So if there are no more questions, and this is it from today's class, and tomorrow again we will meet at 10:30 for the same class, MOS. Till then, Hafiz and take care.